Hey everybody, I'm Chris from SparkFun. The project I'm going to be showing you today for the first engineering roundtable shoot is a sign I'm making for my Burning Man camp. I've always wanted to make a big light up sign so that I can see my camp easily at night when I'm out kind of lost in the desert. The original design for the sign is meant to look like a no vacancy neon sign, and my camp is called Camp Do Nothing. So instead of no vacancy, the sign is going to say do nothing. I've never worked with neon, nor do I think I want to. So I had to come up with a way to make it look like neon, but use EL wire, because that's what I'm familiar with, and it travels a little bit better than neon itself. This is the front of the sign. The frame is just built kind of crappily by me out of plywood and 2x2s or 1x1s. To get the effect of the neon, what I did was I drilled holes where the letters would go, and then I bought some 1/2-inch tubing that I painted with some frosted glass paint to kind of diffuse the light that was coming out of them. And then I took EL wire from SparkFun and pulled it through that tubing. And when it lights up, it looks just like neon. I didn't want the sign to just be lit the entire time. I wanted it to be active, so something was flashing or blinking. Like the no vacancy signs you see in movies or at a hotel, where the no bit is flashing as if the neon controller is going out, I wanted the do to flash as if it was going out. EL wire is different than an LED or an incandescent bulb in that it works on phosphorescence. That's what provides the glow. Inside this blue EL wire, there's a thick wire covered in phosphorus and a very thin wire that is, the opposite signal. It runs off of an AC voltage as opposed to most digital electronics which run off DC. Because it's AC, it's not polar, and the way it works is it acts as a capacitor. Normally, EL wire has 1 nanofarad per foot capacitance. When this is connected to an AC voltage, the EL line as a capacitor charges up, and then when the voltage inverts, it discharges. And at about 120 volts AC, this is happening fast enough to excite the phosphor in the wire, this coating on the thick wire, and which makes it glow. To work with the EL wire, you're going to need a power source, which can be, in this case, 4.2 volt LiPo, just a DC battery. You're going to need an inverter to then take that voltage, that 4.2 volts, boost it up to 120 volts AC. If you've seen EL wire out in the wild before, you're probably seeing it with these all-in-one power source inverter things. We sell these at SparkFun, and they are the best if you want to use just 1 strand or 2 strands of EL wire and just make it blink or be constantly on, because you put 2 AA batteries in this thing and it works right out of the gate. It has a JST connector on it, and the EL wire we sell comes with a JST connector. You plug it right in, attach it to whatever you want, and you're good to go. But if you want to do something a little more interesting, you want to have it fade or blink in sequence, you're going to need some sort of sequencer. To do this project, I'm using one of SparkFun's EL sequencer controllers. And it's kind of cheating because this is the prototype for the new revision, but it works just like the EL sequencers we sold in the past. It has 8 lines that it can drive, a controller, and inputs, outputs for an inverter and a LiPo battery. Each of the 8 outputs has something called a triac on it. A triac is essentially a AC voltage gate. It can be turned on and off, and that's how we end up sequencing the lines. The controller sends the control signals high and low on each of the 8 lines, allowing the AC to flow. The thing is, because this is such a high voltage, we're working with capacitance, and the controller is only designed to drive so many feet of EL wire. You don't want to turn on all 8 outputs at the same time. You don't want to be driving 8 lines at the same time. In fact, I don't even like to drive 2. When you get that much current flying around, things can get messy. The controller might reset if there's a reverse voltage, any number of things, which is why EL wire can be frustrating to work with. But how do you make it look like you have all 8 on at one time? Well, this is where the sequencing comes in. Using one inverter, you can light 8 lines, and even though they're technically not all on at the same time, it's sequencing so fast that your eye can't tell the difference. To light 8 lines, I would send line A high for, say, 10 milliseconds, turn it off, send line B high for 10 milliseconds, turn it off, and then you can start to mess with the timing to the point where they're sequencing so fast that it looks like all of them are on at once. And you can change certain lines. If you want them to, one to be off longer than the others, or one to be brighter than the others, you just turn it on for longer than the other strands. I've got 22 lines of EL in this sign, and so I'm going to need 3 of these. Each of the lines except for the do part is just going to be on all the time. I want the do to flash. So if I have 8 lines and say 3 of them are the do, the red EL in the do part of the sign, I will sequence those differently. I'll have them on for shorter amounts of time, but more frequently, so that even though the do is flashing, and it's on the same controller as the other lines look like they're on all the time. This is the bottom of the sign. What you're seeing is the tubing with the EL wire through it sticking out of the bottom, and I've kind of duct taped it down so I can work with it. Normally it comes with these nice pre-terminated JST connectors, but I had to cut some to get shorter or longer lengths. That means I'm going to have to splice new JST connectors onto the EL wire. In this wire there's an outer colored coating of plastic, there is an inner coating of plastic, and under that is the thick phosphorus coated wire and 2 real tiny signal wires. Now the way you splice these things, strip off all the plastic, cut the ground wires down just a bit so that they're not touching bare phosphor, and then at the top of the phosphor the top of the phosphorus wire, you have to scrape off that coating of phosphor in order to solder to it. I use these pre-made JST connectors from SparkFun. The polarity doesn't matter, so solder one end to the the line with the phosphorus shaved off, the other end to the very hair-like small wires. When you're done, you can just tape this up. It's okay for the small signal wires to be touching the phosphorus coating. That's how it creates the capacitance, but they cannot be touching the bare part of the phosphorus coating. Now this is nice because it means that the other end of the EL wire does not have to be terminated. I can just cut this anywhere I want and it will still glow as long as it's hooked up right at one end. When you're doing a project with EL wire, rarely are you installing it on a workbench. You're always, sewing it into clothing or putting it on a huge sign or a bicycle or, some complicated implementation. Which is why I'd like to talk about the tools that I'm using. One in particular, we sell at SparkFun a butane soldering iron. I think it's less than $20. This is the most indispensable tool in my toolbox. This thing is super portable. There's no cord. It fits in your pocket. It's much easier than having to drag out an extension cord, plug in your soldering iron, worry about a stand. This thing has a stand already built into it. When I first bought this, I did not think it could do the kind of soldering that I wanted it to, but I have done surface mount small pitch soldering with this thing. And the way this works is it has butane in it, just like a lighter, and you turn it on and gas starts flowing, and it has a sparker that it comes with, and you spark it up, the element inside heats up to an orange glow, and in about 10-15 seconds it's able to melt solder. And when you're done, you can just turn off the butane and it has its own stand. So if you're into doing big projects like this, where you're going to have to be moving around and doing a lot of soldering, I would definitely recommend this soldering iron. Well, thanks for watching Engineering Roundtable. I hope you understand a little bit more about EL wire and how to use it. And be sure to check out our next episode in about 2 weeks.